Logistic regression is used to predict a binary dependent variable. So in this case, our binary dependent variable is adoption, which is represented by 1 or 0. 1 means the customers have adopted the product, which in this case is a new phone, and 0 means they have not. And we're going to try to predict the likelihood of adoption using two variables, age and gender. And this will allow us to identify some of the characteristics of our target market. So to do so, we have to go to Analyze, then Regression, and then Binary Logistic. In this window, you can add your dependent variable, which is adopt in this case, and your independent variables, which are age and male. If you click OK, you will have your results here. So the last table shows you your coefficients and the level of significance. So as you can see, both variables are significant because the p-value is almost 0 or close to 0. And then because logistic regression is a likelihood model, then the beta coefficients represent log of the odds. A negative log of the odds represent a decrease in the likelihood of the outcome variable. A positive log of the odds represent an increase in the likelihood of your outcome variable. And then the exponential beta represents odds ratio. And then here, a number below 1 represents, again, a decrease in adoption, and a number above 1 represents an increase in adoption. So what does this table tell us? It tells us that 1 year increase in age decreases the log of the odds by negative 0.033. Or in simple English, older people are less likely to adopt the product. And then for the male variable, this tells us that males are less likely to adopt our product compared to females. And as we said, both variables are significant. And then a model fit statistics is the table above here, which is classification table. And this table allows us to see how good or bad our predictive model is in predicting the data set that we just ran. So observed represent what actually happened to the customers, and then predicted represent what our model predicted based on those customer characteristics we have in this model. So let's try to read this table. So here the table tells us that our model predicted 58 of those who actually did not adopt the product to not adopt the product. So these were correct predictions. And they're called true negative. Negative because the prediction is 0. Prediction of 1 is referred to as positive. And then when the prediction is wrong, that means it's a false. When the prediction is correct, that means it's true. So we predicted them to be negative, and we were correct. That means we have 58 true negative. And then our model predicted 35 of those who have not adopted the product to adopt it. And those were incorrect. That's why this is called false positive. So we predicted them positive, which is 1, but they were false. So again, true negative, false positive. And then in the second row, we have predicted 22 customers not to adopt the product, but they have actually adopted those products. So this is incorrect, which means it's false negative. Again, it's incorrect, that means it's false, and we predicted it as 0, so it's negative. And then we predicted 85 of them to have adopted the product, and they actually have. So those are correct, and the prediction was positive. So that means it's true positive. Now our model predicts adoption better than non-adoption. As you can see, 79 or almost 80% of the adoption prediction was correct, compared to about 62.5% of correct non-adoption. Overall, we have about 71.5% prediction rate